Hey everyone, this is Ahmed Halek, and this is the recordings for the implementations that we have done in the lab before. We did the Uni-Directional Association, we did one-to-one, we did one-to-many, we did, I think, many-to-many, I believe. I'm going to go through all of this again, just for the sake that there's a recording that you can refer to, right? And as well as the documents is going to be available as well, right? These recordings should have been uploaded like a couple of while, should have been made and uploaded a couple of days ago, but I was really sick and I couldn't do that. These recordings like 2 days ago on Thursday. So I hope that you excuse me on this one. Alright, so let's start with the association, Uni-Directional Association. Let's take a simple example that we have a car class that has all of these variables: license number, price and year, car make and car model, right? We have a car ID, and notice that there is a car count, right? This is a class, a shared variable, a class variable. All of these are instance variables that are special for the car object itself, right? And we have the get price method, and we have the set price method. All of these are instance methods because you don't see the line underneath. A line underneath means that this is a class method or a class variable. Like this is, in this case, this is a class variable, right? So we don't have any class methods. No method at all has the line underneath. So all of these are instance methods. Like every method that is going to be created from this metaphorical class, any car that is going to be created is going to be having all of these instance methods, instance variables, and instance methods. Right? We have an object or a class for person. This person is going to have only for the time being the first name. Let's just call this name, right? And let us make all of the instance variables private. You know that Python doesn't have really private and public, but let's just consider that all of these had the name mangling thing that I've told you about. That if you want to make something private, you can just add the name mangling here. But I'm not gonna add the name mangling because it just makes things a little bit more complex, and not complex, it's just gonna make things really difficult to handle, and I just want to make this recording as simple as possible. So let's just assume that all of these variables are private. This shared variable is just shared across all of the objects, so that's why it's public. And let's try to implement this. Let me just go to trials, and I'm going to make a Jupyter notebook like the one that that I have open right there, right? I think if you installed Anaconda, you can check this by searching Anaconda on your machine. If you have Anaconda, I think you can do the following. You can open a Jupyter notebook just by saying a new file, just typically as you create any file. And let's call it something, any name, UML, for example, code, right? .ipynb. Okay, it's gonna take some time to initialize, and finally, after it initializes, you're gonna have this busy right there, or Python 3 idle, right? So click on this and choose the conda. You can have any Python interpreter that you want to use to run this script, to run the cells in the script, but I'm just gonna stick with the conda here, right? And just to test that everything works, write anything and it should give you the result right there. You can either run by clicking on this button right there, right, or on this button to run this specific cell, or you can hit Control Enter, right? You can hit Control plus Enter, right? Why do I'm introducing Jupyter notebooks? It's really good for testing, like having something on the side to test quick cells, just some stuff in specific cells, then going back to your Py script as you see there, right? So let's discuss the class. Let's say class person is going to have the constructor. The constructor is going to initialize. Notice that the constructor is an instance method. That's why it has the self keyword. This is an instance method, right? So the person only have a name, right? So whenever we initialize a person, we should give it a name. So in the instance bool, I'm going to create a name that I'm going to take from the user, which is this argument, right, whenever he creates an object of person, and this object is gonna, or this argument is gonna be taken when the object is being created or instantiated and be placed into the objects or the instances name variable, like that. And let's just make a represent function or method to just say that any object that is going to be created, I don't want it to be, all right, let's just put this like that, and let's create an object of person. Let's go to the other cell. Let me just run this and create an object of person and put it inside P1, for example, right, and give it something like Ahmed, right. If you want to check that object, right, P1, you're gonna have this ugly thing that tells you that this is an object of person that is located inside a memory location of that hexadecimal address. So in order to represent this a little bit differently, and in a way that we can read that this object belongs to some specific person, we can just say represent, and instead of returning this by default, we can return something that is readable to us, something like, for example, the name of the person, which exists in the same object that is being created, right? Again, this is object creation, or what we call instantiation. Okay, so now if you run this, let me just run this. If you run this, you're gonna have that the object of B1 is basically returning or belongs to a guy that is called Ahmed that we created. Whenever you create an object from person, this argument is being passed into the constructor of that person class, right? Which is the init method. This init method is the constructor, right? So the argument is being passed whenever we create an object of person to the object that is being created, to the object's class instance method. So this is the instance method, and this is the argument that we're passing. It's being passed right there, and it's being passed again into self.name. So if we check on the pool of variables that P1 has via dict, for example, you're going to have that this object has only one instance variable, and this instance variable is initialized into Ahmed, right? And now, how about we do the following? All right, this is the person class. How about we do the the car class, right? So let's make the constructor, and let's say that, let's see what does this have. It has all of these variables, right? So I'm just gonna copy them and initialize them like that. Of course, I'm gonna take all of this away and put self, and we don't really need this board, so I'm just passing the license number, price, year, car make, and car model. All right. I'm going to pause the video. Okay, I've just removed all of this excess thing that we got from this port. I've just removed the types from there, and I put every argument into its place, into its instance variable, like that, right? What's left is the actual ID. So this is gonna be dependent on a shared class variable that's called car count, right? So let's just initialize this with 0, and let's say that whenever an object is created of car, right? So I'm going to do the following. I'm going to increment car count with 1. Now this is gonna produce an error, because I told you that if you are inside an instance method, okay, and you are trying to access a class variable, all right, so this is an instance method. How did you know that this is an instance method? Because of this self here, because this is the constructor to begin with. Okay, so if an instance method is trying to access a class variable, this is a class variable, because this variable is initialized outside of the constructors. That is what makes it actually a class variable, right? This is an instance method or instance variable because they are initialized inside the constructor, which is an instance method. And because they have all of this self thing, this means that whenever an object is created of car, all of these values are going to be found in that specific instance, specific self, in that specific object, right? So if you want to access from an instance method, you want to access a class variable, then you should say to what, like you should specify to what class does this variable belong. Like this variable in this case belongs obviously to the car class. So we just need to say that this variable belongs to the car class. I can find it in the class variable area. This is the class variable area, which is between the class definition and the constructor. This is the class variable area. So I can find the car count in the class variable area. So I'm just gonna increment this and put the current value inside the car ID, right? So now let's create a car. Okay, so I'm just gonna say that this is car 1, and I'm going to create a car that has I'm gonna assume that the license number is a string, as you saw here, because it may be alphanumeric. So I'm just gonna give it some random stuff like that, and let's just give it a price. This is arbitrary, and let's give it something like 2012, and let's give it the car make something like Toyota, and let's give the car model something like Corolla. Right, and let's hit run. Now it's gonna tell you car is not defined. We need to run the cell again, and now we have the car object. Now let's print what this car object actually includes. You're gonna see that it has all of these. This is in place of the license number, and this is in place of the, as you can see here, this is in place of the price, and this is in place of the year, and so on. So all of these are the instance variables. Notice that the object, when you say dict, right, on an object, it's gonna give you the instance variables. You notice that you cannot see the car count here because the car count is a class variable. If you want to see where the actual car count is having a value, you should say that I want to print the dictionary or the pool of variables that the car class actually have, not the object. So this is going to tell you that we have a car count of this should be 100, right? We have a car count of 1. Okay, so we created one object, we have a car count of 1, right? So this is the class variable inside this car class. All right, now let's do the following. Notice that the car ID here is 1, right? Let's continue this and say that I will give it a get price, set price, and display all of these instance methods. Right, so let's say pass here. It's gonna take an amount, set price, pass as well, right? So get price should return the price, right? So it should return the self price. And remember the data hiding thing or the implementation detail hiding thing, where it's not really a good practice to say that I'm going to access from car, right? Let me just remove all of this. It's not a good practice to say from C1 I'm going to get the car model, or let me just say price, for example. That's not a good thing. That's not a good thing to access the object and directly access the instance variable. So that's why the concepts of getters and setters exist in object-oriented, where you actually create a function or a method that gets you a value of a specific instance, or you make a method that equivalently sets a value for a current instance variable, right? That's because I don't want to directly be able to access the actual instance variable or the variable on that instance, but I want instead to have an interface or a gateway that does that for me. This is a better practice. This is a good design practice as well. So instead of doing this, I'm just gonna say that get price returns price, or returns self.price, and this set price actually grab the self.price and assign to it the amount that we are passing, and finally display just display the car details. So this is gonna be something like, say, car here, car details. Okay, so car ID is equal to car ID, like that. And I have a couple of stuff. We have car, what do we have? License number is gonna be equal to this license number, and we have the price. So this is car price, and we have the year, and we have finally the make and the model. Okay. Now let's try all of these things. Let's create a car object and say that I'm going to access that object and say car, for example, or c1.display. What do you call it? Display specs? Display specs here. There is a small error. It takes 0 positional arguments, but one is good. Yeah, we should have said that this is an instance method. So all of them should take actually self, like that. And let's just run this again. Let's run this again, and let's run this again. So it's gonna tell you that this is the actual details of that car. All right. Now, as you can see here, this is the implementation of what we did so far. There's no actual relation yet. So let's make a association where we store the car inside person. Right. So I'm just gonna say that using the attribute text notation that inside person there's gonna be a car, right? So this is gonna have an object of car, right? Which this actually can be omitted and just make a line like that. I'm just gonna do this in a second right now. Okay, so let's say that person actually has a car. There are multiple ways to do this association. First of all, let's try the basic one, where whenever you create or you register a person inside the records, you say that this person, this current person, is having the following car, right? So I can say that inside person I have a variable for car, as you see here, right? So I'm just gonna create an object of car and pass it to this person, right? So that object is gonna be passed into that car instance variable inside person, right? Okay, so now the initialization of that object actually is different. Now we have to create the car first and pass that car object into that person. So let's create this and check the specs. That's not what we really want. We want to see the actual pool of variables for that person. Now you see that that person has this car that we created, which is Toyota Corolla, right? So we can just make a representation for that object of the car to make it look a little bit better. Okay, now let's return the actual car make. Let's say that this is car, for example, car ID. How can we return it? Let's write something that is a little bit readable. I'm thinking of a way, but it's gonna look lengthy. So yeah. However, this is the car ID. So that anyways, let's just put the car make, and let's put the car model here. I think the ID is important as well, right? Self.car ID, and we have car make. Let's just say car make and model at once. So this is gonna be self car model. I think that's it. Now let's run this one more time. Now let's see this. You see that this person owns the car that is called that has the ID one, and car model, make and model is Toyota Corolla, right? And that's the typically the association here. So the association is done via this field variable or instance variable or field reference as we call it. So this is what actually created the association for me. All right, so this is typically the what we call this is the attribute text notation, right? If you want to have this using the association line, then we would omit this variable and just create a line like that into that class and say that this is, this is for the time being, this is navigable from one direction. Like if I have the person, I can know the car, but currently if I have the car, I cannot make or know who is the owner, and hence the unidirectional thing that we're talking about. This is unidirectional, so the navigation goes from one side only to the other. So from person I can know the car, but it's not vice versa. So I can say, instead of having the attribute here, that I can put what we call a role name, right? And that role name is actually the variable name that we have inside person, which is in this case the self-did car. That was in the attribute text notation being placed here instead of having this line, right? Okay, now there is one problem here. We're saying that this is, of course, is one-to-one, so I'm just going to place this here. And assuming that the person can have only one car, and this car can be owned by one person. Okay, so I'm going to revise all of the relationships types in the video that I'm going to label as guidelines for relationship implementation in Python from UML to code. But for the time being, I'm showing you a current example of how can you implement association, and we're going to see shortly bidirectional association and composition and inheritance as well, right? So association and aggregation basically have the same implementation, which is basically the object is created outside, the object is created somewhere in a different script, and then that object is being sent, right, is being sent to the object of the other class, right? This is association, and it's the same implementation for aggregation as well. Now we have two problems with this approach. The first one is that first of all, I can have a person, like I can create a person like this, but let's call, for example, Ali, that for the time being he doesn't have a car, so it shouldn't, it shouldn't always have a car. Like you shouldn't record a person with a car. Like you can have a record for a person that does not own a car for the time being. So this can be solved easily by saying that the object car is going to be a default or an optional parameter that is going to be by default none, right? So if this person has a car, then all right, initiate an object, instantiate an object of that person and pass that car to him. If that person does not have a car, then that's fine. Do not send any car object to that person, and that's end of story. That's it, right? So if I created this guy, person 1 and person 2, and I tried to get the dictionary for both of them, dictionary, let me just print like that, you're gonna see that Ahmed has the car and Ali does not own a car. So the first problem has been partially fixed. Now what if I say something like, all right, Ahmed or Ali that I've created, which does not own a car, at some point in the future he wants to own a car. So this is a screen for me to add a method that actually allows me to add a car. For a method, we can say that actually the relationship between the person and the car, which is the association name, can represent the actual method, right? So we can say that something like, this is the association name, All right, the association name, which it's in this case owns, right? Own the car or have a car, whatever. Okay, so we can implement a method that actually does that association name for me. This method can be inside person or it can be inside car. The practices are saying, good practices are saying that this method should be inside car, but from an implementation point of view, it's not that really strict. You can do whatever feels readable for you and your team, whatever you feel that is it makes logical sense for you. So I'm going to show you first how can we add a car from have the method from person, and how can we add it from core. What is the difference between both of them? Okay, so I'm just gonna have the method right there, and let's just call it um, add car, and this car basically takes a car object, an object of core, which is of type core, and it takes it and adds it to this core variable right there. Okay, so let's go to core, or let's go to person and define add core. So this is an instance variable, an instance method, I'm sorry, because it takes self like that, and it takes the core object itself. So the core object is being sent, or object core, what did I name it here? Just make it core object for consistency. Okay, so I'm just gonna take it and assign it into self core like that. Okay, and hence we can say that core is now, let's say own or reserved, is now core is owned. Core got reserved. You have successfully reserved this core. Let's just call owned this core. Okay, all right, so this is add car. Now one problem you would see is that what if I try to assign that car, which is car 1, which belongs to actually Ahmed. As you see here, Ahmed has the car which has the ID 1, which is Toyota Corolla, right? If I try to assign it into person 2, like say that Ali now wants to add that car to him, which is C1. Okay, I think we need to initialize this one more time. Okay, now it's telling me that car got reserved. So if I check this one more time, you're gonna see that, oops, that's interesting. Oh, that's my bad. I should have gave person 2, which is Ali, which is person 2, I'm sorry. So car got reserved. Now check this. You're gonna see that Ahmed and Ali owns the same car, and that's basically violates the multiplicity. We say the multiplicity here is that a car is owned by only specifically one person. So that it breaks that multiplicity on the end of the person. So what should we do in this case? We can solve this with simply a small flag at the car, saying that, for example, car, let's say, is reserved or is owned, and set it to false. Once we actually own this car, once we add a car like that, okay, we can say that now this car is this car is owned. So we set this to true, right? So before we add a car to anyone, we should check on something. If in that car object that is being sent, if is owned is false, meaning that the car is not owned by anyone, then go ahead and own it. Else we would want to say that the car is already reserved. Alright, so car is already reserved. Okay. Now the same thing goes here whenever we create the person. Now we want to check, right? So if for example that object car that is being sent at the object creation of person, if that object car is owned, or in other words, if it's not owned, then just add it there. Okay, and we can even have the same message being printed, right? So you can just have this message like that being printed to me. Okay, but else we would say that the car is already reserved. So let's initialize this and initialize these guys. Okay, so there's a small problem here. It's saying that the error is at this line. So what happens when we create the person? Notice that the car here is none. There is no object being sent to Ali. What is going to happen is that this none object that does not exist when we create the Ali person, right? This none is being checked for is owned attribute, and none object does not have an attribute, right? So we need to make sure before we do this check that there is an object car to begin with. So let's say that there is an object of car to begin with. If there is, then this is the time to do this, right? So this is the time to actually check this, do the same check that we have done there. Okay, so there's something missing that I forgot to do, is that whenever the car is not owned and we try to own that car, we'd want to say that this car object needs to be set, this flag needs to be set to true. The same thing goes here. Okay, now let's run this. Yeah, the inconsistency again. Let's just name it, all of this, let's just name it the same thing. Car object, like that. Okay. Alright. So it's telling me that this person has already reserved the first car successfully. So if I check Ahmed, you're gonna see that Ahmed has this car right there, right? And maybe we can say that else we would just assign this to none. Maybe someone does not want, whenever he creates a record for himself, he does not want to get a car assigned to him, right? So just assign this into or let's say no, let's just do something different. Let's say that if there is no car object at all, I'm just gonna say something like that. This instance car variable, you can just set it to none. Okay, now let's create this. Now check both of them. This guy does not have a car, but this guy has a car, right? Now if I try to assign the car 1 into B1 or B2, which is Ali, alright, that's not correct. Car is already reserved. It's gonna tell you that the car is already reserved and car is already reserved by someone else. Okay, so he cannot reserve it, and you can see that Ali does not have any car owned by him. Okay, the same thing goes whenever I try to initiate and instantiate a person object, another person object, right? Let's name it, for example, Muhammad, and try to give him car 1, which has been owned by Ahmed. This is person 3, like that. It's gonna tell you that the car is already reserved, and if I check on Muhammad pool of variables, you're gonna see that he does not own any cars. That's not correct. It should have a car of none. Alright, so this should be inside else as well. Like if this car has already owned by someone, we would just say self none, like that. Okay, now let's instantiate these objects and try to give Muhammad car 1. He wouldn't take it, and else he's gonna have this car variable as none. Okay, one small note in this code. This code actually, to me, is like a code smell, because you see that there is a redundancy. This part typically looks like this part. So why don't you just stick to the convention that whenever someone needs to add a car, let him just use the add car method. Like, there is no need to have all of this inside the constructor. Remember, the constructor is there to initialize what can be initialized. It work should be simple. It doesn't have to have so much logic in the constructor. It's just made for initialization. So I'm just gonna take this part. I'm gonna refactor it into just simply self.car or car object, right? And let it have none, right? We call this as car, right? We said here that this is gonna be called as car, right? So now whenever we want to add a car, we're going to use the add car method. The object is going to be sent. We're going to check if the car is owned by someone. If it is not, then we are going to append it into that car, right? And we're going to change that object is owned, right, to true. Okay, so we should not be able to pass it or to other person who wants to add it afterwards, right? And if it was owned, then the car is already owned by someone else. Okay, so let's run this. This does not take any arguments anymore. And let's check the dictionary for both of them. Now let's say that B1 wants to add car 1, so the car got reserved. Now check this B1, which is Ahmed. Now let's try to do the same thing, but for B2, right? So let's let him just try to append car 1. He won't be able to do that, right? So if we check that, B2 was not able to add the car to him, so the car is none. All right, so what if we try to append the same car again to myself? Like, what if I try to say that I already have this car, right? It's gonna tell you that the car is already reserved. I want to be more specific and know exactly who is the owner of that car. Is it me or is it someone different?